Hello everyone. Let's start a new questions about describe the application of RS and GIS in area of water resource management with suitable examples. This question is asked in GTO exam in 2023. Now let's see what are the applications of remote sensing and GIS in water resource management. Remote sensing and geographic information system are powerful tools for making water resource enabling efficient monitoring, analyzing, and decision making. This application in water resource management enhance planning, conservations, and disaster management efforts. Below are some key applications along with suitable example. First is a watershed management. Remote sensing. Satellite imagery can help the physical characteristics of water such as topography, land cover, and vegetation. This information is crucial for understanding water flows, runoff patterns, and area prone to erosion. GIS. GIS is used to analyze watershed boundaries, calculate drainage networks, and simulates water flows. It helps identify crucial areas requiring conservations of restoration to reduce soil erosions and manage water flows. Example like in India, the Integrated Water Management Programs IWMP has used GIS to identify priority watersheds for conservation efforts in semi-arid regions. Second is the flood monitoring and management. Remote sensing helps real-time satellite data from remote sensing allows for a monitoring of rainfall intensity, river levels, and flood plains, providing early warning for potential floods. Radar data such as from a Sentinel-1 satellite is particularly helps in tracking water levels during monsoon seasons. GIS GIS based flood models helps in mapping flood prone areas by analyzing terrain, drainage patterns, and land use. This helps in flood risk zoning, emergency planning, and designing flood mitigation structures like levees and reservoirs. Example: the Brahmaputra River basin in India is monitored using remote sensing data for flood predictions, allowing authorities to issue early warning and reduce the impact of flood. Third is the irrigation planning and management. In remote sensing can detect soil moisture content and monitor crop water requirement using multispectral imagery. This helps in identifying areas that need irrigation, optimizing water use in agriculture, and preventing water wastages. GIS is used to map and manage irrigation networks, ensuring efficient water distributions. It helps in planning irrigation canals, reservoirs, and identifying areas where water conservation measures are needed. Example, in Punjab, India, GIS and remote sensing technologies are used to monitor irrigation efficiency and ensure equitable water distribution across agricultural fields, enhancing crop yields while conserving waters. Surface water and groundwater monitoring. In surface water monitoring with remote sensing is used to monitor surface water bodies like lakes, rivers, and reservoirs. Change in the size and water levels of these bodies can observed using time series satellite data. GIS is used to map underground groundwater aquifers and monitor their depletions or recharge rates by integrating remote sensing data and well data. GIS helps in creating groundwater potential maps that guide suitable extractions. Example, in the drought prone areas of Maharashtra, GIS based mapping of groundwater resources has helped in identifying suitable site for bore wells and ensuring sustainable groundwater use. Fifth is the water quality monitoring. Remote sensing, satellite imagery, especially hyperspectral and multispectral sensors can detect change in water quality parameters like turbidity, uh, chlorophyll concentrations, and temperature. This helps monitor the health of rivers, lakes, and coastal areas. GIS allows for the spatial analysis of water quality data, identifying sources of pollutions and areas that require remediations efforts. It integrates various databases like land use, industrial discharge, and agricultural runoff to assess the impact on water quality. Example, the Ganga River Basin Management Plan employs remote sensing and GIS to monitor water quality along the river, identifying pollutions hotspots and guide efforts for cleaning the conserving the river. 6 is a rainwater harvesting and conservations. Remote sensing helps in identifying potential sites for rainwater harvesting by analyzing land cover, topography, and rainfall patterns. GIS help use GIS tools are used to model catchment areas and design rainwater harvesting system by integrating data to terrain, local use and rainfall. GIS helps in optimizing the placement of rainwater harvesting structures. Example, in Rajasthan, GIS and remote sensing are used to design rainwater harvesting structure in arid region to conserve water and recharge groundwater levels. 7 is a drought monitoring and assessment. Remote sensing helps in detecting drought conditions by monitoring vegetation's health, soil motions, and rainwater patterns using satellite imagery. Vegetation include like a normalized difference vegetation index (NDVI) are used to assess the impact of drought on agriculture. JS is used to create drought vulnerability sorry to say maps by combining climates, soils, and land use data. This map help in assessing the risk of drought in different areas and planning mitigation measures. Example, the National Agricultural Drought Assessment and Monitoring System NADAMS in India uses remote sensing and GIS to monitor drought conditions and provide early warning to farmers. Reservoir and dam management. Remote sensing RS provides accurate data on reservoir water levels and surface area changes, which can monitor over time. Satellite data helps in monitoring water release from dams based on storage capacity. GIS is used to manage dam catchment areas, model water flows, and assess the impact of dam operations on downstream areas. It also helps in designing spillways and managing sedimentations in reservoirs. For example, the management of Bhakra Nangal Dam in northern India incorporates GIS for water flows modeling and reservoir capacity assessment, optimizing water releases for irrigation and hydropower generation. So the integration of remote sensing and GIS in water resource management provides a comprehensive approach for sustainable water uses, disaster mitigations, and infrastructure planning. This technology enables real-time monitoring, efficient resource allocations, and informed decision making, ensuring long-term soil scarcity. Thank you.